and welcome. My name is Piers Ridyard, CEO of RDX Works, a core developer of the decentralized finance protocol Radix, a public ledger entirely focused on bringing DeFi to the mainstream. Today, I'm doing an interview with our founder, Dan Hughes, and we are going to be doing some technical AMAing. It's going to be a short one today. We didn't have that much time, but we're going to be bashing through some of our most recent questions from August from members of our team. If you want to ask a question, just jump into the Radix channel and hashtag AMA, and we will get to what we can. So, first question.
I would just like to say I absolutely love being back in the office for 2 hours after a wonderful vacation and having these hard technical questions. So thank you, community, for that.
Did you have a good holiday?
I'm still in sunshine mode.
Are you feeling rejuvenated?
Somewhat. Well, I was until I turned up here this morning. Yeah.
You're welcome.
Anyway.
Dan. You're welcome. So,
sure.
Question from Peter Kim. Also, I want to ask how you can trust an indexer or the Radix Gateway. The question almost got answered by Piers on the interview. I know anyone can run a full node and get their own indexer. However, since this is horizontally scalable, i.e. Xi'an is horizontally scalable, won't this come into centralization at some point? What's the team's approach on this matter? So let me just give a bit of background on this. So what Peter Kim is saying, when Xi'an comes along, the network is going to be processing very, very large amounts of data. Now, to be able to submit something to the network in the first place, you kind of need to know what the state of your assets and all of the other stuff is. So you have to be able to go, I want to spend 20 rads. You need to know from somewhere what your balance is, so that you know whether or not you can ask for that. Now, in the way that the Radix engine works and the way the transaction manifest works, you can still submit that to the ledger, but if your balance isn't 20 rads or more, then it will fail, because you basically submit. You don't choose choose inputs. You just indicate intent in the transaction manifest, and then the network works out what inputs it's going to use for that. However, if you don't have that balance, then you can't do that, right? So now, there's two layers here. The first is the consensus layer, which is where everything is actually being validated and goes, is this particular state transition valid? Yes or no? And then consensus is applied to that, and Sybil protection is layered over that. But then there's the question of, like, how do I know what is the current state in the first place? Which is a different question. Like, so imagine if you're building a DEX, right? And you've got thousands of pairs, and you want to build some kind of interface to that, so you can see all of these thousands of pairs, like what all of the current prices are real time in all of the pools based on the balance between these two pools. Now, this is something that SushiSwap has to do and Uniswap has to do, but when you get to something the size of Xi'an, when you're doing millions of transactions per second, that then becomes a real data problem. Like, where do I get that? How do I as a user or as a client work out what I need? And so we were talking about what we've already started to do with Olympia and Babylon, which is this idea of an indexer. So it's called the Gateway Service, and the Gateway Service is designed to allow you to run a full node. And the node doesn't actually have to be a consensus node. It's just listening to transactions that are happening on the state transitions, and then dumping that into some kind of database format that allows you to run queries across it. And then you can scale the gateway service horizontally, because you can add multiple sort of clients on multiple servers on top of it that allow you to deal with thousands or millions of requests, right? Now, the question is if you've got a really big network that's doing very large transaction volume, you're starting to go into the terabytes of storage, potentially on a weekly basis that you'll go, or more, or a daily basis that you're having to store. So doesn't that mean that the indexes themselves are potentially going to tend towards decentralization? Because the bigger they become, the more resources they need, the bigger a server farm you need. Now, that doesn't mean that the consensus itself is centralized. It just means that the data service that you need to query what you want to do, like what your state is and all that kind of stuff, it tends towards, because it's essentially, I need to just have a massive server farm with lots of storage. So the question here is, what's the approach to the matter on centralization versus decentralization here? And Dan, over to you.
So yeah, this is this has kind of just been one thing in the big super things that I've been looking at with Cassandra and stuff. And I mean, it stands to reason, right, that if Xi'an is doing tens or hundreds of thousands of transactions a second or whatever, then if you have these dedicated indexes, then the storage requirements are going to get large. The infrastructure required to run them is going to get large, and so they're going to centralize, right? You end up with a handful of them that hold all of the index state the clients would query to say, hey, I want to make this transaction. Here are the state inputs. What's my balance, et cetera, et cetera. And you run into issues around like potential censorship and stuff like that. Or if they have failures, right? One of them goes down for whatever reason. You can't create transactions as a client for a period of time. And so one of the things that I was investigating was how, in a sharded network where the state is predominantly fairly uniformly distributed across that sharded network, what kind of load does heavy queries put upon the network if you didn't have indexes and you just like global indexes, but you had maybe local shard indexes, right? And they could be the validators or just full nodes in much the same way. The full node could just be an observer to the consensus process in that shard. But instead of storing everything, they just store and index in what they have within that shard space, right? And the approach that I took was the more intensive one, where I didn't have, in Cassandra, I don't have these kind of dedicated indexes. The validators themselves do the indexing, and when clients query them for information, they return that information. And the performance hit in terms of consensus, I mean, there is some performance hit there, but it's not outside of the bounds of what a fairly moderate off-the-shelf node could handle. And you've all played around with the Twitter demonstration where, you know, there's tens of terabytes of information stored on a Cassandra sharded instance, and you type in someone's username or you search for hashtag, etc. And your browser then sends a search query to the network as a whole, and then all these individual queries on these individual kind of local indexes happen, and you get the results back, and you can build them as a client. So from an implementation point of view and from a cost point of view, it's not too kind of negative. It could be done that way, and like benchmarking as such, which I haven't done a lot of yet with this, but you could probably handle thousands of queries per second per shard. So as you're scaling up, you'll be able to handle quite a lot of client interactions, client queries and stuff. Going to your example, around a DEX for a particular pair, you would actually know which shard group and which shard that information would live, right? There would be a piece of state that holds the current price for that pair. So you wouldn't have to do a broad search. You could just do a very focused targeted search, right?
And equally on that, with the gateway service, you could build your own specific gateway service that was just listening to that part.
It just loops for that stuff. Yeah, you could if you wanted to. Yeah. So from a decentralization point of view, being able to do it that way obviously mitigates the centralization nature of big fat indexes, right?
Yeah.
But there is obviously a use case for that. Whereas if I'm a large financial company that's providing a service, and I want a particular level of service, and I want an agreement with somebody who can go and kick the door down if things don't go right or something breaks or whatever, then an indexer there is obviously the more interesting choice, right?
Right.
And around financial regulations and stuff as well, the indexer could filter that stuff out for these companies, and that's fine too, right? But like the reason I looked at it from this point of view is that one is curious. We hope we have a nice load balanced state distribution, and we have plenty of horsepower in these individual shard groups. So is it possible to do these complex searches across a sharded network, and what are the response times like and how late it is and stuff? And if you've used the Twitter demo, it's pretty damn quick, which is good. Spent a lot of time on getting that fast. But also like the indexer that method of doing it, there are different pros and cons for each, right? So from the point of view as you as a client, if you're a user or if you're a company, then those pros and cons will enable you to make a choice.
Right. And I think that this is like what you're talking about here typifies the approach that we take. We try and take with everything, which is like it's a question of choice, and like what are the things that you want to accept as a user. You can't have everything. Like there's always this thing in technology, like completely decentralized and guaranteed SLA and guaranteed response time at all times. You just can't get that. You can't have both of those things. But if you want to have a check at the bottom where you are happy with latency, but you want to do that to increase sort of like the decentralized nature of how you're querying this ledger, then you can have that. Then there's also, I think in between there's some stuff that I think is going to emerge as well. The graph, I think, is an early indication of where these kind of things are going to go as well, where you can have some kind of decentralized service that builds up around the kind of queries that people want to ask, and then there's some kind of way of charging for use of those queries, but the system itself is based on a decentralized system. Like anyone who's been watching the crypto space for a while and is like really ginned up on crypto Twitter will have started to see people talk about this concept of data availability as like a thing that people talk about, because when you start to shard systems, you start to have this question of, well, how do I know whether or not the output is correct in the first place, or how do I know what the correct inputs are? Yeah. This comes into sort of data availability. Now, with Radix,
this is not new, by the way.
No, this
it's just a new buzzword for it, right? It's the current. Hey, what about data availability? It's like, yeah, that's kind of needed.
So, anyway. Like, I think there are a lot of approaches to doing this in just different ways on Radix, and we've built our query layer to be separatable from specifically separatable and scalable in and itself from the actual node architecture, which is completely different from how Solana and Avalanche and Ethereum do it. By the way, those two things are very tightly knitted, whereas here we've separated them out, so you can horizontally scale a query layer without having to then like build a load more nodes on top of the network as well.
Yeah, like the query layer that is implemented in Cassandra is very simple, right? So you can't do any of these complex database lookups like joins and unions or all this kind of thing. If you need that, then on your client side in your application, you need to write the logic to do those things. Right. So all I can really do is send a request for a particular piece of state, or send a request for send me the state that's associated with this particular address, and I'll get those responses back. And then if I need more complex interactions, then I have to do it myself in my app, right? Or an indexing service, they will probably have a lot more. They would probably have a more complicated, a more SQL-like interface where you could do those things, right? And the reason I haven't done that on Cassandra is because unions and joins are expensive, right? So it's just simple queries only. And then all of the demonstrations that I've built on Cassandra are, in a way, kind of testing, okay, what can I actually build with these simple APIs, these simple lookups, these simple indexing queries? What can I build, right? And quite surprisingly, to me, is that we can build quite rich applications with just those, simple fundamentals, and thinking about how do I use these results. So you can do a lot with it, but if you need these complex interactions, then you would have to look a different way or build the logic yourself that deals with them when you get your results. So it's not a generic kind of query layer. It's just send me this, send me that, associated with this, state from there, and then you digest it yourself, or you can go to an index,
or you can build your own on just the substate on the network that you care about, right? So second question, post Xi'an. This is from Maxi G. Post Xi'an, how is it possible to verify that transaction history that is presented to you, for example, on radixscan.io, no offense, guys, has not been manipulated? Does this require verifying the entire ledger state, or is it possible to verify a small portion of the ledger? If it's possible to verify a small portion, does this scale linearly? I.e., if I'm interested in one millionth active addresses, would it take one millionth of the resources? I think I've done the right number of zeros there. I was scanning it without counting. Yeah, it was 1 million. Yes.
So obviously if you've got a monolithic state layer, which is a blockchain, right? So like Bitcoin or Ethereum or something, then everybody in the network that's a validator it knows that whatever it has locally, it is valid because it will have received that transaction when it was synchronizing, it will have processed it locally, verified itself, trust and verify, right? That whole mantra of this space. And it will have committed it to the ledger. And from a client's point of view, if you query Ethereum or Bitcoin transaction, you get back a bunch of information like the Merkle hash for the particular block that it's included in, et cetera, right? And if that transaction wasn't valid in any way, then any blocks that it was included in wouldn't have been accepted by the majority. So you've got a fairly strong means of determining that this particular transaction was verified at this time in this block. I can see all the proof of work or whatever above it, and I know that it's valid, right? Everybody's accepted that block. Everyone's mind on top of it. But when you start to get into sharding, it's not quite that simple because you may have many blockchains operating in parallel that aren't really cross-interfacing with each other, things like Merkle hashes and all that kind of stuff. And I feel like I've gone blurry. Have I gone blurry?
You've gone a little bit blurry. Hey.
Oh, no, I'm back. Hey. I'm back. I'm dealerted. So then let's say that I want to make a transaction from one shard to another, but they're two distinct validator sets, right? Then one set of validators isn't going to have the knowledge. It's not going to have the information. It can't trust itself that it's verified this thing because it hasn't seen whatever was in shard A that's now coming over to be processed in shard B. So you need some way to communicate the validity of something that is being used from shard A to shard B, and that's where what I call in Cassandra are called state certificates, right? So there's a transaction that's processing, that's taking something from A and it's moving to B. So I'm spending something or whatever I'm doing. So previously on A, there will have been another transaction where whatever I'm now spending has been moved from somewhere else, right? So shard P for Piers, and Piers has spent something to somebody, and that now lives in shard A, right? And then Piers now, whoever received Piers' funds now wants to send them, say, to me, right? And so the validators in shard D, let's say shard Dan, they will receive this transaction that wants to be processed, but they don't know if, did Piers really send whoever was in A those funds, or is this just a spend attempt for something that doesn't exist or whatever? And this is where state certificates come into play, because when P is sent from P to A, the validators on both of those shards will have created state certificates for the execution of the transaction. They would have included who had voted that the transaction was good or bad, depending on which way consensus went with it, right? Who voted, how much vote power they had, right? Proof of stake and all that kind of stuff. A bunch of other things like the Merkle hash of the proposal it was included in, the hash of the proposal it was included in that shard, all this stuff, right? Very self-contained. So from the point of view of the validators in shard D, to process this transaction, they need an input, right? Okay, so I need the state input, which is the information in A. And validators in A will send to D, here's the proof that this transaction is spending something that is valid. And the validators in D will receive the state certificate, and they can verify all of those things, right? The validators that voted, how much vote power they had, if it was a quorum decision or not, what proposal, what Merkle hash, et cetera, all those things. And that is enough. That is enough for validators in D to be able to go, okay, you know what? We can trust this. We can trust this enough. We can process this transaction, and we can move on. Now, that makes the assumption that there are less than F faulty replicas, faulty validators in A, right? So you're kind of making that assumption that if this checks out, then the strong assumption that you make in consensus theory is that you have F number of faulty replicas, and if the number of faulty replicas exceeds F, which is usually 2/3 of your full validator set, then bad stuff's going to happen and you shouldn't trust anything, right? But the issue is in a sharded network is that you don't actually, you can't objectively determine if there is F faulty or non-faulty replicas over in A, right? You don't have that information. But one thing that you can rely on is the fact that when the validators from A send you this state input, you're not getting the state input in D from just one, right? Because all the connections are different, yeah? Some replicas in D are connected to different replicas in A and vice versa. So when the replicas in D request this state input from the replicas in A, a different replica in A is going to send this information to a different replica in D. So if you have more than F faulty replicas in A, and they've caused a safety break there, right? In that crazy bad situation where they've caused the safety break, your replicas in D will get different state certificates for the same state, right? And because they get different state certificates for the same state, because they've been, they're fraudulent certificates, so long as D isn't also in that situation where you have greater than F, then they will all reject because you won't have a quorum of agreement. So you have a safety break here, conflicting state certificates will go over to D, and all the good replicas in D will say, whoa, hold on, I've got two conflicting state certificates from A for this particular transaction, so I'm just going to abort this transaction. I'm going to vote no, this is not going to happen. So that's kind of a full, I guess, end-to-end example. Right. It's fairly simple. There are other edge cases too as well, but they get resolved in largely the same way.
So the fact the you rely on a few things here. One of which is finality. Like once a state certificate has been voted on, it's final, and so you have this concept of consensus is finished on this. It's not going to change the outcome of this. Is not going to.
You can't swing your vote. You can't cast a different vote if you're following protocol, right? If you're faulty, you can, but that'll get picked up.
Right, and then you're relying on the fact that there's essentially a sampling process across shards, which means that you can't hide the fact that the shard hasn't actually come to consensus, or it's very difficult to hide the fact that the shard hasn't come to consensus.
Because even locally, right, if I as a replica, let's say that everybody else got the same certificate from all the bad in A, right? And let's say that over in D, I got two conflicting state certificates somehow, right? So it was almost hidden, but not quite. Yeah, I see these two state certificates, and I can inform everybody else. Whoa, hold on, guys! I've got conflicting state certificates here. Right. Yeah,
and that also goes into things like proof of stake slashing and stuff like that. Because if you
and all that kind of stuff,
if you have state certificates that are signed, you can't fake signatures. Like the signatures of the nodes had to have come from those nodes, and if they were faulty or malicious, there is now proof that they have been faulty or malicious, and that would then lead to punishment on in the secondary systems like proof of stake.
Yeah. So it's fairly robust.
That's the great thing about
there are cases where it can still fail, right? Because these systems can always fail. Yeah, if your adversary is strong enough and they have enough influence in the network, then they can always fail. But from the point of view of the accepted bounds of assumptions that all consensus mechanisms rely upon, then they are met here.
Right. And if you are pushing fake goods into the network, and the only way of pushing fake goods into the network is essentially by signing something that is irrefutable proof that you have been faulty or malicious.
You just shot yourself in the face, right? So it better be a damn good attack that makes you a shit ton of cash, because after that point you're out, right?
Right. In question here is, does this require verifying the entire state, or is it possible to verify a small portion?
No.
And the answer
all
is,
you need to verify is these very self-contained states. Like the validators in D don't care at all what else the validators in A have. All they care about is that I've got this explicit, verifiable, self-contained piece of information that, under accepted assumptions, I can verify, and as long as it doesn't violate any of those bounds or assumptions that I can make, then I'll accept it as good.
Okay. Going on to the next question, which is by General Wu. and it's a long question with a short answer.
Yeah.
Hi.
Basically, is asking if there's a piece in the paper about Core Cerberus, and he's querying about GS and FS, distinct replicas, regarding accepting a state transition, essentially, and that actually is incorrect. It should just be GS, not GS minus F, or it should be identical outcomes from 2F would also be correct.
Right. So he's picked up he's correctly picked up a error in the paper, and so that's
typo. Because yes, otherwise that would mean that you don't have a quorum and you actually only have F good replicas saying this is good, and actually you always need 2F plus 1 good replicas.
Right. As you say, a typo rather than a mistake in logic. Yes, exactly. Okay. I will pass that on to the team. Next question by Michael. Will there be a betanet phase with a bug bounty program before the Babylon release? The answer is absolutely yes, but details will be released closer to the relevant time. So yeah. And then the next question is, how do the different shards reach consensus on the order of transactions? I saw some mention of logical clocks, which I've never heard of, but seem to be lamport clocks. But Cerberus doesn't seem to use logical clocks. Am I right? More like reaching consensus on the order using a first commit rule.
Yeah. So the Cerberus paper doesn't go into some of this stuff, right? These are some bits and pieces that weren't deemed necessary to include in the paper because it would cause a lot of confusion. We just wanted to keep it strictly, these are the different variants of Cerberus and how they operate. But there is a lot of peripheral stuff that you need around that to be able to actually implement a Cerberus network. And the order of transactions is one of them. Now, another part of the reason why it wasn't required is that you don't strictly need the strict ordering between shards. You can just have it like loose, because if you think about the way that clients are presenting transactions and stuff, then your different groups of shards, your different validator sets will eventually get to processing these particular transactions at some point, right? So they would just kind of halt that Cerberus instance if they had an acceptance in their shard, and over in a different shard it wasn't quite accepted yet, so there would have been no communication yet. So this emergent Cerberus instance over here would just halt, and other instances of Cerberus would continue, but this one would halt until there was some communication from the other validator sets and the other shard groups signaling that, hey, I'm ready to do this, right? So you don't need a strict order, but if you don't have a strict order, then what generally happens is that you have lots and lots of these emergent Cerberus instances just sitting around doing nothing, waiting for other validators and other shard groups to get into the same state, right? And that obviously increases finality of these transactions, because these validator sets are just waiting around for a period of time, which it could be a second, it could be 10 seconds, it depends what else is going on the network, right? And this showed up real early in Cassandra, like within the first month of development. So one of the things that I implemented is a weak synchronization of mempool across shards and shard groups that are common to a particular transaction, right? So if I've seen a transaction that is touching my shard and Piers' shard, then I will send some information to Piers to say, hey, I'm ready to process this now. Are you ready to process this now? And if I don't get anything back from Piers, I don't put it into a proposal yet, right? When I hear back from Piers saying, yeah, I'm ready, we can go ahead with this, then I will then include it in the proposal. Now, the reason it's weak is that because in the meantime, Piers might have actually had some other transactions that intersect, kind of were concurrent on some state, and he had some other reason to include it in a proposal, so that's why it's weak, right? I could be ready. He could say he's ready, but then something changes for Piers that means he's now not quite ready again yet.
Mm-hmm.
And so in the worst case, I then create a proposal and I end up with an emergent Cerberus that sits around for a little while.
Mm-hmm.
But this weak synchronization across these shard groups, once I've seen a supermajority from Piers and his shard group, and I've seen a supermajority from my shard group on, we're ready to do this now, I can then order that in the next batch of transactions to include in proposals. So I get a weak total order for transactions across the shard groups, right? So I'll be sending information to Piers about when I'm ready. I'll be sending information to all these other different shard groups depending on what transactions I've seen and what shards they touch. Piers will be doing the same, and so will everybody else. So you get this weak synchronization of, okay, we're ready to process this now, and then you actually include it in a proposal which gets accepted locally. And this weak synchronization means that, other than in the rare cases where something's happened for Piers and he has to do something else, you also get a fairly tight synchronization of execution as well. Because in my proposal, I will accept it. In Piers' proposal, in his shard group, he will accept it. We will exchange all the state inputs we need fairly synchronously. Like we'll be fairly synchronized over that. Execution will happen. And then the state certificates are produced, the commit happens on both sides at about the same time. So this weak synchronization reduces all of these emergent Cerberus instances that are kind of just hanging around waiting for all the other validator sets to get to that transaction just by chance. Whereas this weak synchronization means it's a lot tighter, so your finality drops a lot, the efficiency of execution and stuff also increases. So that's how you get a weak total order across shards.
And the logical clocks, the mention of logical clocks or lamport clocks that you'll have seen is reference to a previous version of our consensus called.
They are actually used in this phase as well, right? Because I send to you, I'm ready to do this,
right?
And I've got a clock there,
right?
And then when you respond to me, I then reference my clock to order all the responses, right? Because there's some latency between us. So the logical clocks are used not as extensively as they were in Tempo,
right.
but they're used there just to allow me to go, okay, so now in my proposal, I can order them this way. I got all these responses back. So there's the logical clocks are useful there.
Cool. Okay. I think that will be the last question for today. But some really interesting stuff as always. Please do keep asking your questions in Telegram. We don't always get to all of them. We are getting to the point now where we get a lot more questions than we can necessarily cover in the time that we do. But we do go through them and try and do what we can in the time.
Just on ending, there was another question which was relevant to the one about verifying the transaction history. There's one further down by Trezania, which is also essentially asking the same thing about fraud proofs, right? So the answer that I gave earlier on about state certificates and the mean self-contained, that's relevant to that question too.
Right. Awesome. Thank you very much, Dan. And thank you everyone for listening. And we'll be back in a couple of weeks. No, we won't actually, because I'm going to be traveling. Right? I'm traveling. So we'll be back in a month with the next set of AMAs.
Well, I'm back from holiday now, so I'll keep you all entertained on Twitter and Telegram. So.
Thanks, everyone.